So we got our little basket now, and we can do some calculations on it. One thing we can do is measure the volume of the basket, and then we can actually use rice to fill it up and use a measuring cup to measure how much rice it was. We could check our calculation. We can do the calculation by a formula, and then we can check it with the actual measurement, direct measurement of the volume that it holds. So let's do that. And it's an interesting shape. It's got a square bottom and it's got a round top. But if you look at it, it's pretty much round all the way down, almost to the base. It's pretty round. So let's approximate the shape of this thing as a cylinder, top to bottom. And the formula for the volume of a cylinder, or anything like that, anything that's symmetric like that, is the area of the base times the height. But we're not going to use the area of this base because this is the square. We're going to act like the whole thing is round. We're going to get the area of the circle there, right? So you can even trace around it like this. In case it's not clear what you're dealing with, because it's kind of an empty circle, you say that's the circle, that's the base. But what we're going to do is measure the diameter of that, and then we're going to find the radius from the diameter. So I measure there, and it's not that symmetric, it's kind of wonky. Here it's 10, here it's 9.5, here it's 9, here's 9.5 again, here's 9.5. I'm gonna take about 9.5. So the radius equals 9.5. So that means, no, sorry, that's the diameter, 9.5. The radius is gonna be half of that, which is 4.5 1/4, so that's 4.75. Okay, that's the radius, that's the diameter divided by 2. All right, so then the area of a circle is pi r squared, and so that's pi times 4.75 squared, and I'll whip out my calculator. 4.75 squared, and I got 22.6 times pi equals 71, and that would be centimeters squared is the area of the base area. Okay, so that's the area of this. And then to get the volume, you just multiply it by the height of the circle. And the height of the circle is 11. Measure it one more place. That's 11. Now every kid's gonna have a slightly different dimension. So just make sure they're measuring it correctly. So then you got the height as 11. So now the volume equals 71 times 11, and that would be 781. All right, that's the volume of this thing, 781. But what's the units? Well, this was centimeters squared, and this is centimeters, so now it's centimeters cubed, 3 centimeters, which makes sense because it's a 3-dimensional thing, right? It's got width and length and height. So it's centimeters, centimeters, centimeters. And 781 of them. All right, so now let's check it. Let's fill it with rice. We can fill it with water, but we have to put some plastic in there first, and it'd still be a huge mess. So if we use rice, it should be Should be good. You know, rice is a solid, but if you think about it, it acts like a liquid, like sand. Sand's a solid, but it acts like a liquid. Life is complicated. I'm gonna put it all the way up to the top, right over to the top there. Let some go on either side. And there it is. Okay, so then I'm gonna take this measuring cup, and I'm gonna try to dump all the rice into the measuring cup, except it might not fit, so I'm gonna fill it up to the top. I'm gonna use the metric side, which is 500 milliliters. Milliliters, that would be the same as centimeters cubed. So I'm gonna look at it like this, and look at it straight from the side, try to get it nice and flat across the top there. Okay, that's 500. 500, I dump that back in the rice container, and then I dump the rest in. Okay, and then I'm gonna measure what this one is. Make it nice and flat, and bring it up here, and I see that it's 250, or 260, 270. I call that 270. All right, so that was the volume. That was a volume calculated. I'll call that VC, volume calculated. And this is the VM, volume measured. That's 500 plus 270, and I got 770 milliliters, which is equal to 770 centimeters cubed. All right, so that's only, you could subtract them, and you get 11 centimeters cubed difference. Well, that's not bad. If we just had a paper, somewhat irregular paper basket, and we measured it like that, and we got that close to the right answer, that's pretty good. But still, you could try to think, why did that come out? Why did the measured one come out less than the calculated one? Well, if you remember back to the very first step, we estimated that, we approximated this thing as a cylinder, but it's not a cylinder, it's got a square bottom. Well, a square, if you have a square and the square goes all the way up, that's very different than a circle. A square will give you a different volume than a circle. So let's work that out. What's the volume of the square if it was a perfect square? All right, well, that would be the area of the base times the height again. Okay, only now the area of the base is 8 by 8. So that's 8 by 8, and the height we already measured is 11. So that's 64 times 11. 64 times 11, it gives us 704. Ooh, that's a lot less. That's also in centimeters cubed. That's a lot less than 780, 770. So with the same perimeter, the same circumference, if it's a square, you got less volume. And it's well known that the circle is the shape that maximizes the volume for a given perimeter. Circle's perimeter is often called the circumference, but anything has a perimeter. No matter what your shape is, it's got a perimeter. But if you want to if you have a certain perimeter and you want the maximum volume, you've got to choose the circle. So when this thing comes down to a square at the bottom, it knocks off a little bit of that volume capability. And that's probably why the measured value was less than the calculated value. All right, so that's the volume. Now, let's measure the surface area. That's another thing you can measure on a three-dimensional piece like this is the surface area. So now to measure the surface area, we can use the squares. We can use the squares. See, the whole thing is made up of squares, and the surface area will be the base and the walls. Okay, so if we get the surface area like this, surface area equals the area of the base plus the area of the walls. So we can figure out the area of the base and the area of the walls. And we can use the ruler. But first, before we do that, we're going to use these little squares. We're going to use those as our units, because the whole thing is covered with these squares. So we should be able to just count the squares and find out what the surface area is using this informal unit of 1 square. You call it a woven square. All right, so let's do it. On the bottom, you can see there are 4 full squares. That's 1, 2, 3, 4. And then there's a bunch of half squares. I'm going to count them. I'm going to count them 2 at a time. So I count a square every time I get 2 half squares. So that was 1, 2, 3, 4, 5, 6, 7, 8. So there's 8 full squares in the bottom. So the area of the base is 8. 8 woven squares. I'm going to use that unit as a WS equals woven square. Okay, so that's the area of the base. Now the area for the walls, we could go around with the marker and mark off every single one. All right, but let's use a little bit of brains here. Maybe we go around the side and see how many there are. First, we'll count these half ones, see how many there are. 1, 2, 3, 4, 5, 6, 7, 8. There's 8 half squares. So that would be 4, right? 4 full squares. There's 4 woven squares right there. And then the next one, you could count around 1 level up and make a mark. 1, 2, 3, 4, 5, 6, 7, 8, and we're back to where we were. There's also 8 of those. Okay, 8 woven squares. Those are full squares. Oh, but now look, here's another one. Another line, and another line, another line, another line. Those are also going to be 8 squares around. So from here to here, I got 1, 2, 3, 4, 5 sets of 8 squares. So that's 5 times 8 woven squares, and that is 40 woven squares. And then at the tippy top here, at the rim, I got the half squares again. Now let's just make sure there's 8 of those. I think there will be 1, 2, 3, 4, 5, 6, 7, 8, and we're back to where we started. Now, of course there's 8, because they have to all match. So that's 8 half squares, so that's 4 more squares. 4 woven squares. So we got 40 plus 4 plus 4, that's 48 woven squares for the area of the wall. The area of the wall. So I'll put that up here, 48 woven squares equals 56 woven squares. All right, 8 plus 48, 56 woven squares. And that is the surface area of our basket. Okay? So we can write that on the bottom. We can write the area of the base is 8, and the area of the walls is 48, and the surface area of the basket is 56 woven squares. There it is. Now we'll always know when we got our basket. All right. So now we measure the volume, we measure the area, surface area, using this informal unit. Now one more thing you can do is you could measure the surface area using the standard unit of centimeters. We could do that, and then we could compare the two. All right, so let's do that. There's the surface area using a standard unit is going to be the same. It's going to be the area of the base plus the area of the walls. Only now the area of the base is going to be the area of this thing, the square, in centimeters. All right, so we got 8 and 8. We measured that before. So that area is 64. 8 times 8 is 64. And that's centimeters squared. Okay, and then we're going to add the area of the walls. Well, the area of the walls is, it's going to be as if we cut off the bottom, and we could cut down the side here and laid it out on the ground, and we'd have this plus this plus this plus this. Right? And if you squeeze it back into a square, you can see that each side is just a rectangle, and it's 8 centimeters tall and it's 11 centimeters wide. So there's 8 times 11 plus 8 times 11 plus 8 times 11 plus 8 times 11, right? It's just this perimeter down here times the height of the basket. If you imagine the whole thing busted open, it would look like a long rectangle with this little square hooked onto it. Okay, so that means the area of the wall, that's the perimeter over here times the height. And the perimeter is 8 plus 8 plus 8 plus 8. That would be 32 times the height, which is 11. And that's centimeters squared as well. All right, so 32 times 11 is well known to be 352 centimeters squared, and this is 64 centimeters squared. And you add those two together and you get 416 centimeters squared. Okay, so that's the surface area of this basket using centimeters. And it's just square centimeters because we're not talking about the volume, right? It's just this flat thing. Like I said, if you cut the thing open, it would sit down on the table and it would look like this. There's the base, and then the rest of it would stick all the way up to here. So you fold that down and fold this thing all the way around it, and we're just looking for the area of that thing there. So this one here was 8 by 8, and then this one here was 32 by 11. That's the height of it. So we get those two things, and it'd come up to 416 centimeters squared. Now, we could compare there's 48 woven squares here. We could compare that to the 416 centimeters squared. How do we do that? Well, we need to know what 1 square is. We measure 1 square, and it is 2.5. Más o menos, more or less, 2.5. Let's pick another one over here just to make sure. Yep, 2.5 by 2.5. Well, 2.54 centimeters is an inch, and I cut these things to be just about an inch. So it's 2.5. Let's use that 2.5. So we say 1 woven square is equal to 2.5 squared. 2.5 times 2.5 centimeters squared. I could have put all that in the same parentheses, but all right. And 2.5 squared is well known to be, actually, let me check that. 2.5 squared is 6.25. That's 6.25 centimeters squared. That's one woven square. Okay? Now check this out. In algebra, you can do the same thing to both sides. So I'm going to divide this side by one woven square. I'm going to divide this side by one woven square. Now, one woven square divided by one woven square, that's just one. And over here, I have 6.25 centimeters squared over one woven square. Now, if I go back up here and say my area of the walls was 48 woven squares, and then, sorry, I got this down here, I'll write it again. And then I multiply it by 1. There's 1 right here. This 1 is the same as this. Anything you can multiply by 1, there's no problem. Anytime, any day of the week, you want to multiply by 1, you multiply by 1. Nothing changes. So I put this 6.25 up here, centimeters squared, and down here is one woven square. Now I can cancel that woven square, cancel that woven square. And I got the area of the wall of the sorry, I messed that up. I'm not supposed to be using 48, I'm supposed to be using 56. So I'm going to say 56 woven squares, and then I cancel the woven squares, and I take 56 times 6.25. All right, here it goes. 56 times 6.25, and I get 350. 350 centimeters squared. That's not the area of the wall, that's the surface area. Okay, 350. Okay, now we compare that with 416. Ooh, that's not too close. That's quite a ways off. That's like 60. What is that? It's like, let's do it. 416 minus 350. And we got 66. That's a difference of 66. It's not that close, but it's not that far. It's not like 100 times off. It's not even 10 times off. So we call that the same order of magnitude. It's not that different. It's not spot on like when we did the volume, it was really close. But when we did these two ways of getting the surface area, it's not that close. And I can imagine, you can guess that that this measurement here that we got by measuring it like this, maybe it just came out bigger because the thing is a little bit bigger than it's supposed to be. Maybe we didn't make it that tight. Whereas if we measured exactly each square and didn't count the spaces between them, the looseness, maybe this would be smaller. I'm just guessing. But anyway, that's the two ways to get the surface area, and then comparing the two ways between the woven squares, centimeters squared, and then finding out that's the conversion. It's called a conversion factor when you've got the two different units over the top of each other and it equals 1. So that's your conversion factor between centimeters squared and woven squares. Does that make sense? I hope so. All right, so that's just a little bit of the math that you can do with the basket that you just wove.